In this video, I'm going to go through the notes for Chapter 1, Section 1. And in this section, we are going to write and solve one-step linear equations. So we'll be solving for a variable, and what this means is it should only take us one step to find that solution. So we talked a lot about this as we began the year. There are four basic operations in math. They're addition, subtraction, multiplication, and division. And we have these two pairs, right, that are each opposites of each other. So when we're solving equations, we'll notice that one operation kind of undoes the other one. And those two opposites are addition and subtraction, and then multiplication and division. So we can just do a really brief example up above to kind of show what we mean by opposites. So if I have 3 plus 5, that equals 8. And if I take 8 minus 5, I end up with 3. So notice those two things kind of undo each other, right? I add 5 to get 8, and if I subtract 5, I get back to where I started at 3. And similarly, the same thing happens with multiplication and division. So what if I take 3 times 5? I end up with 15. And if I take 15 divided by 5, I end up back at 3. So we're going to use these principles to help us solve equations. First, we're going to look at a couple of different definitions. Equation, linear equation, and then what it means to actually find a solution, because we're going to be using these words a lot throughout the year. So an equation is a statement that two expressions are equal. Two expressions are equal. So for example, if I were to write the equation 3x minus 2 equals 8, this is an equation because there is an equal sign. I'm telling you that this thing on the left is equal to this thing on the right, and these things are both considered expressions. So two expressions are equal to each other. We have an equation. Next, we'll be talking a lot, almost this entire class, we are talking about linear equations. And so I was debating a little bit the best way to define a linear equation, because we could go really in depth or we could kind of go a little more mild. A linear equation is an equation that only has variables without exponents. So I'll show you an example of that in just a second. And also, the main reason they're called linear is because the graph, so if I graph this equation, the graph of these equations, maybe I should say graphs of these equations, are straight lines. So when we talk about our variables having exponents, we would mean something like this. So the example up above, that is a linear equation. And then something like this, if I had 3x with an exponent on it, like that little 2 up there, 3x squared minus 2 equals 8. This would not be a linear equation. because of that exponent. Okay, so we're not going to deal with exponents until maybe the very end of the year. When we talk about a solution is a value that makes the equation true, specifically a value of the variable. So a value for the variable. I'm going to tack an S on here because there may be one variable or there may be more than one. So a value of the variable or variables that makes the equation true. Makes the equation true. All right, so moving on, we'll come back to these words a lot. We're going to be using them a lot, and the quicker we can make sure we understand what they mean, the better. So if we look right down here below, our goal is to solve each equation. So in other words, this does have an equal sign, so it is an equation, and my goal is to solve it. In other words, I want to find the value of x that makes this true. Okay, so for what value, so what number would I plug in right here to make this whole thing true? And some of you might be able to just look at this and say, oh, well, if I had -2 and I subtracted 3, I would then end up at -5. That's true. We really want to focus, though, on this process of solving. Because once things get a little bit more complicated, you're not just going to be able to look at them and figure it out. And I'm going to expect that you can show this process. So what we would do here is we want to do basically the opposite of whatever's happening. And let me explain what I mean by that. I have this value x, and what I'm doing is I'm subtracting 3. So I've got x, and I subtract 3, and that equals 5. So if my goal is to get this x alone, if I want to find that value of x, I need to undo the subtraction. And like we set up above, the opposite of subtraction is addition. So I don't know that I'm going to do this every time, but some people like to draw a line down here to keep it clear that we have two sides of the equation. And so whatever I do to the left side, if I add 3 to this side here, I also have to add 3 to this side over here. That's what keeps it equal. That's what keeps it balanced. And when I do that, that adding 3, that undoes the subtracting 3. I would be left on the left side now with just x. And on the right side now, I've got -5 plus 3. So if I take -5 and I add 3, I end up at -2, just like we said. We're also going to focus on checking our work. Okay, so checking to make sure that that solution is true. And in order to do that, we want to plug back into, I'm trying to think of the shortest way to say this, plug into original equation. Right, so I found that x is 2, and if I want to check that, I'm just going to substitute that back in. So if my original equation was x minus 3 equals -5, well, I found that x is -2, so I'm just going to substitute that in for x. And is this true? -2 minus 3 is -5 equals -5. Yes, this made the equation true. Okay, so that's how we check our work. We plug it back in. So did we do everything? We solved, we showed our steps, and we checked our solutions. Okay, so this is an opportunity where you might want to pause and try the next one on your own. If you're not feeling quite confident yet, that's okay, but you'll definitely want to do that when we get to the back here in a minute. So again, I've got an equation. Two sides are equal. My goal is to find that value of y. That means I want to get that variable all by itself. So I need to undo anything that's done here. Right now I have y minus 2.8. So to undo that addition, I want to subtract 2.8. Since I've done it to one side of the equation, I have to do it the other. If I didn't, then the equation would no longer be equal, all right? It would not be an equation anymore because I would have disrupted the balance. So at this point, you may want to use a calculator. We've got decimals. If we take 0.9 and we subtract 2.8, you're going to end up with negative 1.9. So on the left, we've got negative 1.9. On the right, we just have y. Right? I had y plus 2.8, so if I subtract 2.8, I'm left with just y. And again, we could check our work. If I wanted to check this, I could take 0.9 equals negative 1.9 plus 2.8, and this does check out. Moving on, same thing. Now we've just got different operations. Okay, so this is definitely a point where it would be beneficial to you to pause and at least think about this and try this problem. And then if you're still struggling, come back and see the solution. So I've got negative n divided by 5. And it might help to even just say this out loud. I have n divided by 5. If you remember, we talked about if this negative sign is out in front, you can think of it as being negative n or negative 5. You can put that negative sign wherever you want. For me, it makes a lot of sense to do this, because I'm trying to get n, just one positive n. By doing that, I haven't changed the value of the equation at all. Remember, one negative sign is just one negative sign. So now what I've got is n divided by negative 5. So the opposite of division is multiplication. So in order to get n by itself, all I have to do is multiply by negative 5. And what I do to one side, I have to do to the other. So on the left, I just have n, and I have negative 3 times negative 5, that's positive 15. And again, let's check our work. I'm going to kind of do this a little on the sideboard here. We are going to check. So I've got negative. I can leave that out front, or I can assign it to either of my values. Doesn't matter. Since we switched this around like this, let's just leave it the way we had it. So if I have n is 15 divided by negative 5 equals negative 3. And I've got 15 divided by 5 is 3. I've got one negative here in my division, so this is good. This stuff tends to throw students off a little bit when I've got more symbols in here. I say symbol because this is not a variable, it's just a number. And if you remember, pi is just a number. It's approximately 3.14592, blah, blah, blah. It goes on forever and ever. We normally just abbreviate it, 3.14, but the point is, it is just a number. So we can do math with it just like we would with any other number. Our goal is to get this x value by itself. And right now, what I've got is pi times x. Remember, when two things are right next to each other like that, that implies that they are multiplied together. Same with the right side. I've got negative 2 times pi. So in order to undo that, what do? We're going to divide by pi. Okay. So I hate to say cancels out. We'll talk more about what that really means and what's really happening a little bit later. But the division undoes that multiplication. And so that was just a quick one step. X equals negative 2. And it makes sense if you think about plugging that negative 2 back in here for x, we would have pi times negative 2 on the left and negative 2 times pi on the right. And with multiplication, the order doesn't matter. Next and final one. This one I would definitely try by yourself if you haven't tried one yet. On the left, we've got 1.3 times z. Remember, we don't see it, but that's multiplication. 1.3 times z, however you like to draw your multiplication, equals 5.2. So to undo that multiplication, we're going to divide by 1.3. And this is another one you probably want to use a calculator. I think it's 4. Let me just double check my own self. Z is equal to 4. All right, getting into a little bit of story problem here. Let's read through this, and we're going to quickly use our problem-solving plan that we talked about earlier in the year. So, in the 2016 Olympics, Usain Bolt won the 200-meter dash with a time of 19.78 seconds. Find his average speed to the nearest hundredth of a meter per second. A lot of information here. This is our little hint. The formula that relates speed, distance, and time is S equals D over T. So all of these things, speed, time, and distance, are all related, and this is how they are related. So if we go back to our problem-solving plan, the first part of that was understand the problem. And I told you guys I'm going to kind of break that down into what do we know? What do we know? What are we trying to show? Okay, so that's how we break down the problem. And then the next part of that was make a plan, right? So make a plan or look at strategies. Okay, so we're going to think about these things. And this is a spot where I would definitely say, take just a quick second, see if you can read through this and break this down. What is this problem telling us? What is it asking us for? And how might we attack this problem? So let's look at what we know. We know the year. I don't know that that's going to be important in this problem because it's not asking us anything about that. He won the 200-meter dash with a time of 9.78. Those both seem important, especially since we have a formula that is for distance and time. So we have a distance of 200 meters. We have a time of 19.78 seconds. We want to find average speed to the nearest hundredth of a meter per second. So that's what we're trying to show. We want to show speed to the nearest hundredth. Wait, there's going to be 2 decimal places. In our plan, how we're going to attack this problem is right here. It's given us an equation. It's given us a way to relate all this information. So speed is equal to distance over time. That's what we want to use. So if we kind of just look at all this right here, we've got all of the information in front of us. This is our plan. These are the things I know. I can take this value of distance and I can plug it in for D. I can take this value of time, I can plug it in for T, and we'll have our speed S. So S equals 200 over 19.78. I guess I can leave the meters and the seconds on here because those are relevant. We wanted our answer in meters per second. And now this is just doing the division. Punch it in the calculator. 200 divided by 19.78 is 10.11122, but we only want the nearest hundredth. So that's this place. And if the number after that was a 5 or above, we would round it up, but it's not, so we're good right there. 10.11 meters per second. This is kind of a challenge problem. If you want to try it, I would pause and give it a try. Otherwise, I'm going to go through it really quickly because this video is already getting a little bit long, and then we'll wrap it up there. So we're given this equation, we're given the value of k, and we're trying to find x. Whenever it tells us what one of the variables is, substitute it in immediately. Okay, if it ever tells you what a variable is, plug it in, no questions asked. So x minus 1 over 3 equals k, but we know what k is. K is 3. Now, I'm trying to get to x by itself. This is more of a two-step, so this is kind of where we're going. That's kind of why it's a challenge. The first thing I need to do is get rid of the 3. And that might not be immediately apparent. I always say kind of work further away from x and then work your way in. We're going to do like opposite order of operations. So in order to get rid of that 3, I need to multiply both sides by 3 times 3 times 3. That's going to give me x minus 1 equals 9. And now we're back to our one steps like we've been doing. So I've got x minus 1. So if I add 1 to both sides, that's going to give me just x. X equals 10.